Hey, John here. Let's talk mounting holes. You got a PC board, let's say, and you want to put mounting holes on it. You might recognize this from the 4-layer video I did a week or two ago. Let's say we want to put some mounting holes in the corner of this PC board. How do we do that? Well, a naive approach would be to look over here and say, gee, are there any drill hole objects? No. Are there anything over here? No. These aren't parts. These are controls. These are, I think of them as parts, but these are things that you can put on your board. No, there's no holes. There is a via. If you really wanted to, I suppose you could come over here and put a via right there and then say E to edit and change the drill hole diameter. All right. Yes, that'd put a hole on your board, and you could even put it on a net if you want to. This would be a plated through hole that's, whatever size you want. You could put a bolt through there, and if you did it like this, the bolt head would connect to the ground plane. Now, right now, by default, my vias, are all, let me do this. Why did that not show up? Re-pour my polygons. I hit B to re-pour the polygons. I guess I didn't look closely enough. There's that via hole right there. So I can set it to whatever size I want. Like I said, you can put a bolt through there. That's one way to do it. I think that's probably not a good idea. You could also notice that there's a way to just throw footprints on your PC board. And if you'd looked around a lot, you would have noticed that if you go in by this browser guy, you can actually put whatever you want on there without any regard whatsoever. And one of the things you can put on there, someone created a library of mounting holes. All right, for sake of discussion, let's say I want to drill a hole for an M2 bolt. Now, somebody already created something called, mounting hole for an M2 bolt that is a drill hole which is 2.2 millimeters, a little extra bigger hole than you need, which is perfect. And then some other DIN and ISO rated specifications for mounting holes. So let's just put one of these on here and see what we get. Throw it on the board, hit B. Now, this is a hole. This is a non-plated through hole. And I hit B to re-pour the polygons because it's not part of a net. Let's go to this guy and have a look, see what that really means. Well, there's no copper inside here. That's what it means, a non-plated through hole, right? You can see that the polygon pour on the front of the PC board is retracted some. There's a clearance in here. It's probably the same as this because that's the configuration that the pour has. It says stay away from anything based on whatever we set that to. Maybe it's a 0.5 millimeter. I don't remember. What you've got here now is the naked FR4 or, whatever your PC board is made out of, the fiberglass. So this is a nice way to just put a hole in your board. The difficulty now is if I was to put a bolt in here and the head stuck out and I tightened it up, it would crunch off, flake up the green stuff in this rendering is the solder mask. So it would grind through the solder mask and short out onto this copper. So if you were to do this, you'd really want to make sure that the copper is clear of the bolt head. Or you can always just put a plastic washer underneath the bolt head, and that's fine. Sometimes you don't have enough room and you have to have copper really close to these kind of mounting holes. And then when you're going to have to put a note or tell the guy that assembles your final product to put a plastic washer under that bolt head, right? Now, let's say you don't have a problem, like this particular design does not need all this copper over here. If I click here, notice I'm clicking not on the pad. If I select the pad, I can edit the pad properties, all right? If I click over here, or double click, it'll open the editor. Or if I click here and I'm selecting this entire part, the entire footprint, right? And then hit E or double click there, I get a different editor for the entire footprint, all right? Now, you could argue in this specific example, it doesn't matter because I can edit the same thing in both of those editors. But as you get into more advanced design, you need to understand the difference between editing the properties of one footprint pad and the properties of the entire part. In this one example, the two are very, very similar. In this particular editor, you can lock the footprint. You can't do that if you go over here and edit one single pad, I cannot lock the entire footprint from here. All right, there's nothing in here that says let me do that. I can play around with these clearances, which I'm about to show you. I prefer to edit them in this other editor over here. Okay, first of all, if you're going to put mounting holes on your board, lock the stupid thing so you don't accidentally move it and you end up with some idiot mistake where you have a perfectly beautiful square board and a triangular shaped set of mounting holes just to annoy everyone else that makes it cases for your product. All right, so what I'm looking at down here is the pad clearance and the solder mask clearance. Just for example, for the sake of discussion, I'm going to set these to different values so we can see what they are. Pad clearance says keep the copper this far away from the pad, which in this case is an unplated hole. This guy down here, it says make sure the solder mask doesn't come closer than this to the pad, or in this case, the unplated hole. So what we're going to see here is the solder mask. I'm going to hit B to repour the polygons. We can see that the polygon pour, the filled zone or regions or whatever KiCad calls this, that's this, what filled areas, okay, in zones, it moved this away. The purple thing here represents the keep away indicator of where the solder mask is going to flow. This green thing over here is because I wasn't watching what I was doing, and on the back of this design there's a trace that's right up next to this hole. If you have a design like this and there's no reason to have it this close to the hole, move this thing away, right? I'm going to hit D to drag this and get it out of there, okay? I guess that's a good lesson. Make sure you know what you're doing. Look around on all your layers to make sure when you're putting holes, that's true about any part. Don't put stuff where you don't want it to go. All right. So I'm gonna hit Alt 3 and have a look-see at this thing now. All right. Now remember, the green is the solder mask that they silk screen on to keep air and solder away from all the copper, so that the copper does not oxidize, and so that solder doesn't go where you don't want it and cause bridges and stuff. So you've seen this. This is an exaggerated example of this. If you have a Raspberry Pi, right? Let's say this was a Raspberry Pi, and you know there's a connector on this edge up here. At least in the Pi B style designs, there's a 40-pin connector over here. On the right of that connector, at least in the Pi 3B, or the B plus, or whatever they call it now, there's a mounting hole. If you look very close at the mounting hole, you'll see this exact pattern, although my demonstration, again, is an exaggeration of their pattern. You'll see a non-plated through hole. You'll see bare PC board fiberglass. You'll see the solder mask, and a little bit of a gap in there, and then you'll see their ground plane, their filled region around and underneath this thing, right? So why do I want this to have an overlap like this? Well, if you end them both exactly the same, you have two potential problems. One, if your vendor can't put the solder mask in perfect alignment with the copper, and zero of them that exist can. Even if they say they can, they can't. It's just not possible. No one's perfect. Even if they were, what would happen is that remember that copper has like a thickness, and if you put, you know, it's just essentially paint on that copper, the very edge of that copper is still exposed. And yes, you could end up with getting solder on that little tiny edge and get a bridge if this was plated, for example. Or it can oxidize and work its way in your board. You get chemicals on this or something like that, you can cause problems. So you always put a little bit of an overlap in here. In fact, you should go to your vendor and look up the manufacturer of your boards. Will give you a number and say, here's how accurately aligned I can put my solder masks. So give it more clearance than their worst case accuracy spec in their fabrication specs tells you they can do, right? So let's say time passes on, you make some modifications to your PC board, you come back in here and you want to read in a new Netlist, and you decide I want to delete extra footprints or change them and things like this. What's going to happen? Well, you got two issues. One, if you didn't lock this. Remember, I locked this, okay? If this was not locked and I said read this in and I said delete extra footprints and stuff like that, it would go away. This one didn't go away again because it's locked. But let's say it's not locked for whatever reason. And I usually forget to do this. When I use this technique, I always forget to lock them. And I go on and I make my changes and I go like this and boom, all my mounting holes go away. Drives me nuts. Sometimes you might not even notice. I just report the polygons. Now, boom, it's gone. All that work lost. Okay, fine. Lesson learned. Lock your stupid mounting holes. But let's say for some reason you're not going to lock them, or better yet, you want a plated through hole. Okay? If they're going to be plated, there are actually schematic design elements. So let's go in here and say, look, and you've seen this if you look around, sometimes you find projects, schematics out there, where in the schematic itself you see mounting holes. All right? Now, this is why. They are real design elements. They need to go on the board. In fact, if you have a different person laying out your PC board than you have drawing the schematics, you want to let them know, I want 4 mounting holes. And you even want to name them. You have to write assembly documentation. Here, put bolt in mounting hole, H1, H2, just like you would say, whatever, an op amp, U105. Give them names. This is all part of your documentation that you should have with any project. And you can assign it a footprint just like anything else. And we were just poking around in here. So now I can put an M2 footprint right in here, and that then tells your board designer what kind of mounting hole you want. Now that I have placed this guy and I've assigned it a footprint, I can hit C to copy it. And now that I'm making copies with the footprints in there, I don't have to assign all of them. I can come up and annotate them all. Just do the whole thing. That's fine. There's my 1 capacitor, and here's my mounting holes now. I can export a netlist, I can import the netlist, and these mounting holes will show up just like any other part. Now, I only put 3 in here, because when we were poking around over here, let's show you what both of these mounting holes are for. There's 2 kinds. There's a hole and a hole pad. Now, this is a plated pad, right? Now, you could plate all these if you wanted to. Not only is this one plated, it is a schematic element. Let's move it over here. It has a pin. This is a pin. So let's say for some reason I want to hook up this mounting pad to VCC. I suspect there will be no one has ever done this. Why would you want to put your high side voltage on a mounting pad? 9 times out of 10, you'd probably, if you're going to have a mounting pad that's connected to something, you probably want to connect it to ground, and you want to probably plate it and put a bolt through that hole and check and connect it to like a metal case. So, all right, fine. We'll go for the more realistic view here. Let's edit this thing. We'll throw a footprint on here. Instead of using M2, let's use an M2 with a pad now. And again, if you go over here and hit Alt-3, you can look at it in the 3D viewer. Now, this looks like a pad you'd see with a resistor or something like that, but with a hole that's 2 millimeters in size. And there would be plating inside there. Now, this is perfectly reasonable, but notice there's another one down here, pad with vias on it. Now, this one, if you're really going to hook this up to a polygon pour or something like that, a filled zone, if you have filled zones on the inside layers, like a 4-layer board. That's why I'm using my 4-layer design, by the way, for this video, instead of starting a new 2-layer one. These will run through the board and do a better job at connecting to the internal planes, if this is supposed to be connected to the internal planes, than just this one single plating that's inside here, all right? So this would be the one I would use if I wanted a via that's connected to polygon pours that are in a 4-layer, more than 2-layer board. So I'm going to save this schematic. I'm going to annotate it because I don't have these. All the holes are not annotated. Now they are. Save a netlist. Go in there. Bury this window. Give me this one. All right. Now we're in here. Grab the netlist. Even if I say delete them all and so on, it doesn't matter, right? Because all I've done is add things at this point, close. Now, these come in as regular parts. Like I said, this guy here really is a part. Come on, give me this. If I select the part, they're all too close together. Come on. That one. Hit M. Let's put that one up here. Let's put this guy down here. Just like with any other part and what you saw before, hit B, report your polygons. This one's connected to ground, so you can see that the thermal reliefs are in use here because that's what I told this pour to use. Internal ones that are on ground will also come in around here like this, okay? The back, what is it? Oh, this is a VCC one. If you hit the right click, in on the pores, it says which pore do you want to choose from, and you can see right here the front is on ground, this one's on ground, in 2 is on VCC, and I don't have a pore on the back copper, which is why you only see 3. Okay, so that's what that's all about. Now I have a much better connection between the copper on this pad and this ground plane. Alt 3 this thing. Let's zoom in and have a look see. That's not too bad. Of course, it's gold plated because that's what the exposed copper is going to have on it. Oops, how do I flip this thing over? Here we go. There's the front, there's the back. This over here are the holes that I did not yet put on a PC board. They're out in air. And it's plated and everybody's happy, all right? Now, here's the other guy down here. I did not go and specify the clearances like I did when we first did one. I'll quickly do that just for fun. Remember, if I click here, I'm clicking a pad. If I go over here, I got the whole part. Maybe I want to lock it. Maybe I don't. Whatever. I want a 2. Maybe at a 1.85. Let's say the guy says he's got a 0.1 registration accuracy with his soldering mask. Well, I'm going to go down to 1.5 for my clearance, right? Because I'm going to have 2 millimeters away from the edge of the pad for the copper and 1.85 for the solder mask, which gives me 0.15 clearance leeway. I just hit B to report the polygons, so that this here is 0.15 millimeters of overlap there. A little bit of overlap like I talked about before. So you got your plated, you got your non-plated. The last thing about the non-plated is that all manufacturers can't do non-plated holes. You'd think that you'd have the problem with plated through holes. Some manufacturers cannot do this, okay? If you run into that situation, you have to make all of them plated. And you can either use these ones with the vias around it, or you can just use a regular pad. You saw there were 2 options when we were editing, selecting a footprint, right? If we go back to the browser, that's the pad with via, pad without. These are all pads that have different specifications. That might be that the DIN 965 says that this is supposed to be some specific distance or something, and the ISO 703080 you can see is a slightly different one. It might be that this hole in here is a slightly different size, although these all claim that they're 2.2 millimeters. I didn't verify any of this. I don't know, but we all run into this from time to time. Yeah, there's all these standard organizations that say, if thou shall make a pad for an M5 bolt hole, it must be this big and it must have this kind of clearance and blah, 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 blah. And different organizations have different suggestions. It's nice that somebody has gone through and done this. This is a little anal retentive, but it's just great that you don't have to look this up every time and go through and do this all yourself by hand. That's pretty cool. All right, so there's how you put mounting holes in there. If I missed something or was wrong about something, definitely let me know in the comments. Thanks a lot for watching. Happy PC board building.